In this video, I'll be doing a detailed solution to the maths question you see on the screen here. It's from the Cambridge A-Level exams from 2024, paper 2.2 or paper 2.3. They're actually the same paper. If you're looking for a different question from one of those papers, check out my description below. It should have a link to a playlist there. I'll be doing all this on a whiteboard, hopefully just like you're used to your teacher doing. But remember, we are on YouTube, so take advantage, pause, rewind, or even watch at a different speed. If you do like this video or any of my videos, I would greatly appreciate subscribe, a like, a share, or even a super thanks. In question 4, we're giving two parametric equations. Now that's when x and y are both defined by something else, in this case t. But we still have an xy curve. Like at the end of the day, we're going to have a curve y and x. I just don't know what it'll look like, and it can look really weird. It can go in over itself even. It could look like something here. In this case, t goes between 0 and pi over 2, I think I see. So like that could be, when I put t in as 0, maybe I get this point into both of these. So I get an x and a y point. When t moves a little, it moves like this. So when I get t over 10, I'm here. T over 5, I'm here. T over, and so on. Like I move all the way down to t. T is pi over 2. Then I have no idea what it looks like. The point is, it looks something. It has a look to it, like all curves do. And they want us to know, they want us to find the equation of a normal at a certain point, at t equals pi over 6. So first of all, let's just say this point here is when t is pi over 6. What can be found is a tangent. And all tangents have normals. It's like this. And that's what they're looking for. I just don't know what it looks like. I have absolutely no idea. But that's what we're looking for. So what we really need, we'll need to find this point. And we'll need to find the slope of this normal here. So that's, and if you wrote all that down in English, I think they'd give you a couple of marks. They'd find a couple of marks for you if you tell them, like, this is what we have to do. At least I hope they do, because that's most of the battle. Now let's do the actual work. The first thing I would do is, let's find this point. So this point is when t, let's put it over here, t is equal pi over 6, I believe. Yeah. So I want to know the x value and the y value. So let's just get that. That's x is equal 4 cosine squared pi over 6. Put that into your calculator. It's cosine, let me check my notes. Cosine pi over 6 is 4, will stay there, is square root of 3 over 2, and that's squared. So put that, what's that, 3 over 4, 4 is cancelled, equals 3. That's your x value. Let's put that in here. That's 3, and we'll leave room for the y. And the y value is square root of 3 sine 2 times pi over 6. Well, that's pi over 3, 2 times pi over 6. Put that into your calculator and you will get square root of 3 over 2. Square root of 3 is multiply, we get 3 over 2, and that's the y value, 3 over 2. So we have the point, we just need to find the equation of a line. So how are we going to find the gradient here? How are we going to find the slope? Hopefully you are thinking derivative. Gradient, slope, derivative, they're all the same. So we need to find dy dx somewhere. That's what I want, dy dx. Usually it's easy, we just get y and differentiate with respect to x. Problem is, y doesn't equal anything with x's in it. So we can't do that. We can. It's just a little more difficult. What we can find quite easily is we can find dx dt. We can differentiate x with respect to t. We can also get dy dt. So, I guess, yeah, let's say this now then. Using these two, we can find dy dx. Let me put it in over here. So dy dx will equal dy over dx. You can put anything you want here once you're fair and equal. Like you can put 8 and 8, they'd cancel. You can put 1 and 1, they'll cancel. You can put z and z, they'll cancel. You can put dt and dt, they will cancel. So if you want dy dx, you can just find dy dt and dx dt and divide them, and you'll find dy dx. So that's what we'll do. Let's just differentiate them first. Dx dt, we're going to need to use the chain rule here. This is something complicated happening. This is, remember, this is something squared. So the chain rule will tell us 4. So let's put the 4 in. Let's do the complicated thing first. That's 2 multiplied by cosine t, and then differentiate what's inside. The derivative of cosine is a minus sine t. Clean all that up, we get minus 8 cosine t sine t. And do something similar over here. It's we still need to use the chain rule because this is sort of complicated, not that complicated. So that'll become square root of 3. Derivative of sine is just cosine 2t, and then multiply by the derivative of what's in here, and that's just 2. So let's put that out front here. Okay, so we have both those, so let's just divide them. So we get dy dt divided by dx dt. So that's 2 square root 3 cosine 2t over, this is dy dx by the way, over minus 8 cosine t sine t. That's the derivative of everywhere. Anywhere you want, this is an answer to it. You just tell me what t is, I'll tell you what the slope is, the gradient I should say. Now we do know what t is at the point we're interested in. T is pi over 6, so just start filling that in. We get 2 square root 3, let me again check my notes. Cosine 2 times pi over 6 is, I have a half here. On the bottom row we have minus 8 times, I have square root of 3 over 2. Sine pi over 6, then I have a half. Put a lot of this together, let's see, that's 4 divided into 8. Because 2 times, that's 2 square root of 3, 2 square root of 3, that cancels. We're left with minus a half. Sorry, let me just double check that on my notes. Yes, minus a half is the slope of this line here. So that's where we have to be careful. The point we're interested in, let's put this guy in as minus a half. The one we're interested in is the normal. So many students probably got that wrong. They got the tangent instead of the normal. The normal is the inverse of this. Upside down, change the sign. So the normal is just 2. The slope of the normal. So now we just need to find the equation of that line. Hopefully I can squeeze it in down here. When I find the equation of a line, my favorite method is just to do y is equal slope, which is 2, times x plus some unknown c. Let's find out what c is, because I know a point on the line. So that's 3 over 2 is equal 2 times 2, 2 times 3. I'm just putting in the x and the y values. Plus c, let's see, that's 6. 1.5 minus 6, or let's see, 3 over 2 minus 12 over 2 would be minus 9 over 2. That's equal to c. So the answer, let's put it up here. The equation would be y is equal 2x minus 9 over 2. I would lose a mark for that, because they just gave one more instruction. They wanted the answer in the form of ax plus by plus c equals, so rearrange this, we get 2x minus y minus 9 over 2 equals 0. Unfortunately, I'd still lose the same mark, although you should really only lose half a mark. You've done half the work. They gave one more instruction. They wanted all of these numbers to be integers. So 2 is fine, minus 1 is fine, minus 9 over 2 is not. So let's multiply everyone by 2. 4x minus 2y minus 9 equals 0. That's your full marks for this question. That's the equation of this normal line. I've no idea what it looks like. Let's see, slope 2. I guess at least I got the right direction partially. That was just random guess though. I have no idea what this curve looks like. I could put it in on a computer and find out, but it doesn't matter. It really doesn't matter. And it won't matter in other questions either. Okay, if you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day.